Hello guys, ngasigi video sida oxidation number calculate toba question amakhatang ai sida lakhachage ko. Now oxidation number sida the question hangi si kaino calculate the oxidation number of nitrogen in ammonium phosphate and is for 3PO4, okay, and the sulfur in this, chromium in this, and the sulfur again in H2SO5. So let us take the first question. In the first question we need to calculate oxidation number of nitrogen in this complex, in this compound. So now this is ammonium phosphate. This can be written separately. So this if we do not, this can be separated like this. This question can be solved in two ways. This is ammonium ion and this is phosphate ion, like this. So in this ammonium ion, oxidation number of N is suppose X, and the hydrogen has an oxidation number of +1 into 4, and this charge must be equated to +1. This has no meaning here when we separated the ions, okay, so this has no meaning. So this implies X is equal to -3. So oxidation number of nitrogen in ammonium phosphate is -3. We can solve this question without breaking into ions also. In that case, what we need to take, oxidation number of nitrogen here is X and the hydrogen is what, +1. So for 4 hydrogens, the oxidation number will be 4 for 4 hydrogens, okay, and this will be multiplied by 3, and this phosphate ion has a charge of -3, and this whole charge must be equated to 0 because the compound is neutral. So we will get 3x plus 12, okay, minus 3 is equal to 0, and that this is 3x is equal to, this is what, 9, okay, and that 9 will go that side to become -9. This implies X will be -3. In this way also we can solve the oxidation number of nitrogen as -3. I hope this is clear. This is another way to solve this question. This is another way, this is another way, and this is another way, okay. Okay, let us go to the second question. For that I need to rough this answer part. Let me rough it. देखा अनिस पर क्वेश्चन है आई तो रखे. Okay, in the second question, B, sulfur in what, this ion, this is S4O62 minus. So for this we need to draw the structure of this ion actually. So the structure of this ion is like this. There are 4 sulfur atoms here like this, and this 2 oxygen will be attached to this sulfur, the end sulfur like this, and the 1 oxygen will be attached here, 1 oxygen will be attached here like this. This is the structure of this ion, okay. So now let me change the color of the pen. Okay, see, how many valence electrons of sulfur are there? 6, okay. this is 1 valence electron, this is 2, this is 3, this is 4, 5, 6. From this sulfur 5 electrons will be pulled away by the 3 oxygen atoms. This electron will be pulled away by this sulfur, this oxygen. This 2 will be pulled away by this oxygen atom. These 2 electrons will be pulled away by this oxygen atom, but this electron will not be pulled by sulfur because sulfur and the sulfur has equal electronegativity. Okay, so this will not be pulled. Similarly, in this case also, from the 6 valence electron, only 5 electrons will be pulled away by the 3 oxygen atoms, and similarly here also this electron will be pulled away by this oxygen, these will be pulled away, these will be pulled away, these, but this electron will not be pulled by this sulfur. So from this sulfur, how many electrons are pulled away by oxygen atoms? 5. So this sulfur has an oxidation state of plus 5. This sulfur also has an oxidation state of plus 5. But these 2 sulfur atoms, they will have oxidation state of 0 because sulfur has, their atoms, same atoms of equal electronegativity, so no sulfur will pull electrons from other sulfur. So average oxidation number of sulfur in this ion will be plus 5, 0, 0, plus 5 divided by 4. This will be equal to 10 by 4. 10 by 4 is nothing but 2.5, I think. Okay, this is the oxidation number of sulfur in this complex. But individually, if someone asks, then this sulfur has an oxidation state of plus 5, this sulfur has an oxidation state of plus 5, these 2 sulfur will have a 0 oxidation state. Okay, so from this question also we can find out this 10 by 4 or 2.5 like this. Let us take X as the oxidation number of sulfur in this ion. So there are 4X, and oxygen atom has an oxidation state of minus 2. Minus 2 into 6 is minus 12, and this will be equated to minus 2 because the charge of the ion is minus 2. So this is 4X, and this will come to this side. 12 minus 2 will be 10. This is plus 10, therefore X will be plus 10 by 4, that is plus 2.5. this is plus actually. Okay, this is our plus. So this is the oxidation number of sulfur in this ion. Okay, I hope this question is clear. Let me go to the third question. So for that I need to rough this. So let us do the third question. Okay, third question, C. Okay, C. C, we need to calculate the oxidation number of chromium in this compound, CrO5. Okay, so let us take oxidation number of chromium as X and the oxidation number of oxygen as minus 2. This will be multiplied by 5, this will be equated to 0 because the charge of the molecule is 0. This is a neutral molecule, so that gives an oxidation number of chromium as plus 10. But is it possible for chromium to have an oxidation number of plus 10? The answer is no. Why? Because chromium is 24, so we can write electronic configuration of chromium like this. This is 18 and 4s1 3d5. So how many valence electrons of chromium are there? 5 or 6. 1 plus 5, 6. So only 6 electrons can be removed from chromium, but in this case 10 electrons are removed, which is not possible. So this is wrong. So what is the correct way to calculate the oxidation number of chromium in this complex is through structure. In fact, the structure of this oxide of chromium will be like this. This is chromium. Let me change the color. This is chromium, and 4 oxygen atoms will be attached like this. This is oxygen. This is oxygen. A peroxide bond. This is a peroxide bond. This will be oxygen. This will be oxygen. This is also a peroxide bond, and one oxide is also present. Sorry. Out of the 5 oxygen atoms, 4 oxygen atoms will carry a charge of -1. This is -1. This is -1. This is also -1. But this oxygen is -2 because 2 electrons will be pulled by this oxygen atom from chromium. So this oxygen will carry a -2 negative charge, -2 charge. So what mistake we have done is we have taken -2 for all the oxygen atoms, which is not in this case. Okay, so the correct way is through this structure also. And there are 6 valence electrons of chromium. 1 2 3 4 5 6. Only 6 electrons are pulled away by the oxygen atoms. Therefore this chromium will have an oxidation state of +6, not +10. Okay, not +10. Okay, now so in this case what correction can be done is that chromium X 4 out of the 5 oxygen atoms, 4 oxygen carries a minus oxidation state. So -1 into 4, and only 1 oxygen atom carries a -2 oxidation state. Okay, that is -2 into 1, and this will be equated to 0. So this gives an oxidation number of chromium as +6. This is the correct way to calculate oxidation number of chromium, not this one. Okay, this is wrong. Okay, let me do the final question. For that I need to rub this portion again. Okay, so in the last question, we need to calculate oxidation number of sulfur in this oxo acid. This is kerose acid. This is called kerose acid, peroxomonosulfuric acid, something like this. Okay, so in this case also the traditional way of finding oxidation number will come out to be wrong, like this. Hydrogen has an oxidation state of +1, so for 2 hydrogen +2, and if we take X as the oxidation number of sulfur and -2 for oxygen atoms, and if it is equated to 0, and this will give an oxidation number of how much? -10, I think +8. Okay, so sulfur has an oxidation state of +8. This cannot be true, again, because sulfur is 16. So this is neon 10, and then comes 3s2 and the 3p4. so how many valence electrons are there? 6. So only 6 electrons can be given out by sulfur, not 8. So this is wrong. So again, what is the correct way? This is again through structure, and this is the structure of what? This kerose acid. And the structure of kerose acid is like this. This is the structure of kerosene. This is oxygen. Okay, and out of the 5 oxygen atoms, 2 oxygen atoms will carry a -1 charge because they form peroxide bond. In peroxide, oxygen has an oxidation state of -1. This is oxide bond. This will carry a -2. This is -2. This is also -2. And in the structure also it is clear that how many valence electrons are let me change the color first. Sulfur has 1 electron here, 2, 3, 4, 5, 6. 6 electrons are pulled away by oxygen atoms because oxygen is more electronegative than sulfur. Okay, so this sulfur will have an oxidation state of +6, not +8. And so what is the correct way to calculate the correct oxidation number of sulfur is hydrogen has an oxidation state of +1, so for 2 hydrogen atoms +2. Okay, plus X is the oxidation number of sulfur, and out of the 5 oxygen atoms, 2 oxygen atoms carry a -1 oxidation number, 1 -1 into 2, and 3 oxygen atoms carries a what is the charge? -2 into 3, and this will be equated to 0. And this is 2 plus x, this is -2, this is -6, and this is equal to 0. This -2 and +2 are cancelled out, and this gives oxidation number of sulfur as +6, which is the correct oxidation number of sulfur in kerosene acid. Okay, let me complete this video here. Please like and share this video to your friends, and if you are new to the channel, please subscribe to the channel and also press the notification button. Thank you.